Okay, let's dive into this. When you're writing code, you kind of expect things to follow a certain logic, right? Like 5 is greater than 4, duh. But in the wild world of JavaScript, comparisons can get, well, they can get really weird. So today we're going to peel back the layers on how JavaScript actually compares different values. And trust me, some of the results are going to make you scratch your head. So let's kick things off with a little pop quiz. True or false? The string 2 is greater than the string 12. Now, every bit of math you've ever learned is probably screaming, false, no way. But in JavaScript, the answer is actually true. And figuring out why is the key to understanding all the strange logic we're about to get into. Before we jump into the really bizarre stuff, let's get our footing. We'll start with the basics, the simple comparison operators that, actually behave the way you'd expect them to from a math class. So first up, you've got your standard crew, greater than, less than, and their buddies, or equals to. Then we have the equality check. And this is super important if you're just starting out. A single equal sign is for assigning a value to a variable. A double equal sign, double equals, that's for checking if two things are equal. And its opposite, of course, is not equals for not equals. And here's the fundamental rule of the game. It doesn't matter what you're comparing, the computer will only ever give you one of two answers, true or false. That's it. Is 5 greater than 4? True. Is 2 equal to 1? False. It's simple, it's straightforward, and it's a core concept in, well, pretty much all of programming. All right, let's circle back to our little brain teaser. Why on earth is the string 2 greater than the string 12? This is where we say goodbye to simple math and we enter the world of string comparisons. See, it turns out JavaScript isn't looking at these as the numbers 2 and 12. It's looking at the individual characters. Now, the fancy term for this is lexicographical order, but honestly, the easiest way to think about it is just dictionary order. Imagine you're looking up a word. JavaScript does the exact same thing. It lines up the two strings and compares them one character at a time, moving from left to right. So here's how it goes down. When JavaScript sees 2 and 12, it starts with the very first character of each. It sees a 2 and it sees a 1. And right there, the comparison is over. Since the character 2 comes after the character 1, JavaScript just declares 2 as the winner and doesn't even bother looking at the second character in 12. It's a totally logical process for a computer, but for us humans thinking in numbers, it feels completely backward. So we've covered numbers versus numbers and strings versus strings. But what happens when you throw them all into a blender? What happens when you ask JavaScript if a string is greater than a number? This is where the language tries to be helpful, and that helpfulness has some really interesting side effects. And this is the big rule to remember. When JavaScript sees a comparison between two different types, its default move is to try and turn everything into a number first. So when it sees the string 2 being compared to the number 1, it says, okay, let me just convert this string 2 into the number 2. And then the comparison just becomes 2 greater than 1, which is, of course, true. Now this automatic type conversion leads to a really funny paradox. Get this. The number 0 by itself is considered a falsy value. So if you check it, it's false. But the string 0, because it's a non-empty string, is considered truthy. It's true. So you've got a false and a true. And yet, because of that automatic conversion we just talked about, if you use a loose equals equals to compare them, JavaScript says they're equal. So you can literally have two equal values that have completely opposite Boolean logic. How weird is that? So this automatic type shuffling, this helpful little feature of the double equals operator, is the source of so many bugs and headaches for developers. It's too unpredictable. But thankfully, there is a much safer, much stricter way to compare things. Here's the heart of the problem. Because the double equals equals converts types, it looks at the number 0 and the Boolean value false and sees them as the same thing. In its mind, false just becomes the number 0, so the comparison becomes 0 equals 0, which is true. But a lot of the time, you absolutely need to know the difference between the actual number 0 and a false value. Double equals hides that crucial distinction from you. And here it is, the solution. Just add one more equal sign and you get the strict equality operator, or triple equals. And just look at the difference it makes. Loose equality says 0 and false are the same, but strict equality says nope, not a chance, because it checks the type first. It sees a number and a Boolean, and it immediately returns false without even thinking twice. Seriously, triple equals is your best friend when you want to write clean, predictable code. It basically asks two simple questions. 1, are the values the same? And 2, are the types the same? If the types are different, it doesn't even bother checking the value. It just says false. Game over. It's precise, it's reliable, and it saves you from all those quirky conversion bugs. So, you thought it couldn't get any weirder? Well, welcome to the final boss of JavaScript comparisons, null and undefined. These two special values, one meaning nothing and the other unassigned, they have their own set of rules that just seem to defy all normal logic. So JavaScript has this one special, unique rule just for these two. If you use loose equality, equals equals, they're considered equal to each other and only to each other. But if you use our trusty strict equality, triple equals, it correctly sees that they're actually different types. And so the result is false. Now this right here, this is a complete logical contradiction. Let's break it down because this is where it gets wild. When you use greater or less than, null gets converted to the number 0. So is null greater than 0? Nope, because 0 greater than 0 is false. Okay, so is null equal to 0? Also no, because of that special rule where it only equals undefined. But here's the kicker. Is null greater than or equal to 0? Yes, because it converts to 0, and 0 greater than or equal to 0 is true. So let me get this straight. It's not greater than 0, and it's not equal to 0, but it is greater than or equal to 0. That is a true JavaScript classic. All right, deep breaths. We have journeyed deep into the weirdness, and it might feel like you're walking through a minefield. But the good news is, there's a really simple set of rules you can follow to navigate all this safely and write code that actually works the way you expect it to. Your protocol for clean code is actually pretty straightforward. First thing, just make strict equality, triple equals, your go-to, your default. That one change eliminates almost all this ambiguity. Second, be super careful whenever you're using greater or less than with null or undefined. And third, the best practice is to always check if a variable might be null or undefined as a completely separate step before you use it in any other kind of comparison. And that really leaves us with one last fascinating question, right? If loose equality, the double equals, is so problematic and so unpredictable, why is it even still in the language at all? Well, the answer really goes back to the history of JavaScript and a desire to be forgiving and flexible in the early Wild West days of the web. It's basically a fossil, a remnant of a different time, and a great reminder that the languages we use every day were designed by people, and sometimes they come with some very weird parts.